All right, so in today's video, we're going to be talking about Google's agent-to-agent protocol. One of the latest releases in the protocol game, we're seeing a lot of companies trying to figure out how to be the one that sets the right standard for how agents interoperate with one another. And Google A2A is gathering a lot of momentum. GitHub actually has 17,000 stars as of today. Today, I'm going to be going through everything you need to know about agent to agent to start building on it. And we're going to build an example of an agent using the A2A protocol. All right, so why did Google actually build A2A? I think first thing to keep in mind is that there are countless ways to build agents. There's so many frameworks that are popping up. In fact, every single day there's a new framework. I think these are the more common ones: LangChain and their LangGraph for building agents. That's what actually we're going to be using today. Crew AI, AutoGen, OpenAI has got into the agent space as well with their agent SDK, Google Agent Development Kit. There's so many different frameworks to build agents, and the question is, how are they going to interact with one another? How are they going to communicate with one another? How are we going to be sure that when you build your agent and I build my agent, that they speak a common language? And this is going to become a problem. And that's why Google has decided to go into this space. Now, Google says specifically that A2A is an open protocol that provides a standard way for agents to collaborate with each other, regardless of the framework, underlying framework or vendor, right? So essentially, this is just about interoperability and how agents can connect to one another. Okay, so according to Google, they say agent to agent is a protocol that makes it easy for you to interoperate with other agents. And they go further to say that, the protocol allows you to discover and delegate tasks to other agents. So one agent is going to be out there saying, "Oh, I need to do some kind of task," right? In our case, it's like, "Oh, I want to do some research and some stocks." And this agent is out there on the client side saying, "This is what I want to do," and then you're able to use A2A to discover what other agents are out there doing the same thing, and do they have the skills to do it? And we'll talk a little bit about skills later on. Now, they do all of this through server-sent events. Now, server-sent events just simply means that because of the nature of the way most agents run, what is an agent? Agents are typically reason, plan, act, type entities using the LLM. They're going to call tools. They're going to go through a loop sometimes. So when they're doing their reasoning, they're not it's not just a synchronous call where you say, "Oh, I want this," and then it returns the response back. No, it makes several other calls. It's talking to tools. It's talking to itself. All these different things have to happen before it actually produces the final answer. So what SSE allows you to do is to stream back those responses right as they're happening. So every time there is an event on the server side, you want to stream that back. So in real time, you want to be notifying your clients that this is what I'm doing, right? As an agent, I'm doing this and that. And that is why we use SSE. Now, RPC is also very important here. Is a protocol that is being used to actually trigger functions inside an external service as if it was just like you're calling that service locally. Now, these things are very, very important because I think Google says, well, this is what makes this protocol cool, is that we're using established protocols that have already worked in traditional software, and we're bringing them to work specifically for agents, and that's why they're building it this way. So we're going to dive in and see exactly what makes up an agent, how it works, the different components that you should keep in mind. There's so many of them to keep in mind, by the way, but these are the ones that would allow you to at least get started. All right, so the first component we're going to be talking about is the agent card. Now, the agent card essentially is like a resume or a business card, basically, of the agent. This basically talks about what the agent can do, who created it, a little bit of information about different things about what the agent is all about. So if you kind of think about it, if you're going to be having thousands of agents that are out there and you want to interact with one of them, you want to delegate some kind of task to them, you want to first know exactly what that agent can do. And that's what this agent card does. So they're using a well-known URI JSON object to define all of these attributes. Now, you can go into documentation and see all the possible attributes for an agent card. The next part of an agent is the skills, right? So what are the agents able to actually do? So all the tool calling that an agent can do is making up their skills. So this could be an agent is able to go do some fund analysis or do some stock analysis. We've given it all these different tools that represents the skills. So every agent should have a card and a set of skills that explains exactly what agent does. Now, when we jump into the code, you're going to see exactly how to define those and how they're used as well to satisfy different problems. All right. So Google also says that one of the whole reasons why they have gone into building this protocol is to manage the end-to-end flow of an agent lifecycle. So if you can think about an agent takes some kind of input, usually like a message, and then you start the run, right? The run is going to run, for a few seconds. There's multiple things that happens within a run. And what Google A2A is trying to do is to help you manage all of that. So you don't have to think about, what callbacks do I need to write a function for, or how do I handle, streaming or these types of things, right? So they want to be able to do all of that for you and abstract all of that away for you. So you just focus on basically bringing the functionality of your agent to bear. So other components are important here. Messages, basically communication between the client agent and the remote agent, right? So each message could be either the user, or it could be an assistant role message. All right, next thing is tasks. Now this is so important. Now every agent runs, and there's a task, and this is how you track essentially each run, like the start to finish, like what's going on. So you think about, and I'll show you this in Langsmith as well. When we kind of observe each run, you could see, the various different steps. The agent calls a model, makes some tool call, returns the responses of a tool call back to the agent, and so on and so forth. So these are all the things that happen within a task, and Google allows you to maintain and manage the entire lifecycle using a task. Now, the final piece is streaming. Now, we talked about streaming earlier on, streaming back responses. Now, streaming is so important when it comes to building LLM applications, because you want to be able to kind of get that first token back as quickly as possible, rather than waiting, for a very long time for it to generate everything and return the response back. LLMs are very latent processes. So whenever you're running an agent, it could take, anywhere from a few seconds to quite a lot of seconds as well, right? You can have human in the loop, you can have different things going on. So streaming is so important, so you can get real-time responses back as things are happening. And that's one of the things that Google provides in this particular protocol as well. Now, let's dive into the code. All right, so this is the remote agent we're going to be building. Is an investment research analyst agent. It basically is going to be able to research some stocks, some financial metrics, and we're going to be able to access it from a specific URL. Now, here are the skills that we're giving this particular agent: get SEC filings, get stock summary, get analyst targets, recommendations, and so on and so forth. So give it all these tools, and we're going to expect it to be able to answer questions related to stock analysis. So let's dive right into the code. Hey guys, quick sidebar here. Now, I came across this platform called Cats with Bats. And I have to say, it's one of the most amazing learning tools I've actually used. Now, with Cats with Bats, what's different is that you can chat with the video. You can ask questions when you're stuck. You can copy code right off the screen, and you can even get prompts that you could use for your vibe coding in Cursor or Windsurf. I've actually decided to put all of my content in there, so go check it out. And beyond that, you also find some really amazing tutorials from AI engineers who are showing you how to build and ship real-world AI applications. So head over to catswithbats.com to check it out. I'm going to also drop the links to the description of my videos that are out there. And I want to hear what your experience is when you check it out. Now let's get back to the video. All right, so let's go over the code. Now, by the way, you can skip all of this and go straight to my GitHub and get the code. It's a fully deployable code, which allows you to basically have a Slack client. There's also just a simple client that you could use to test out the agent. We're using LangGraph. Now, keep in mind, you could use several other frameworks. And in the videos to come, if you guys are interested, I can go over how to use A2A with other frameworks. But for now, I love LangChain. I love LangGraph. I think it's one of the easiest ways to get started. Also, there's a ton of amazing observability that comes with LangChain. So I'm using Langsmith for that. So these are the reasons why I use LangChain. And I have a Slack integration, so you could actually deploy this at your company or wherever you might be. Now, when it comes to our A2A, there are several components we talked about already. We talked about the agent card, the skills. So I'm going to show you exactly how all of these works. Now, the key things to keep in mind, one is that you have to define your agent. So here we have our agent right here. So like I said, using LangGraph. So these are all the imports related to LangGraph. And then we're going to be using some tools here. Yahoo Finance is the primary one we're using. So the very first thing you want to do is to define all your tools. So these are all the tools we're using right here. So this is just a typical LangGraph agent that you can build out very easily. And we're giving it all these tools. Now, the one thing to keep in mind with regards to agents is that they want you to kind of use like a class structure for them. So basically, the few things that they expect you to do is to define like a response format. So you want to define like how you want your agent to respond. So typically a status with these specific types. So input required, maybe if your agent doesn't understand a particular message, it can return this status completed, or if there's an error, it can return error as well. So all these actually become part of how A2A decides what to do depending on what the status is as well. So you can have different types of response formats, by the way. I think that's one of the funny things about A2A is like this composability, right? It's interesting because you could actually have different response formats as to how the agent responds. Now you have your analyst agent here. So we've defined it. We've defined what the agent is all about. We've also defined like a system instruction. And then you want to go ahead and initialize it. Okay, so what model are we using? So in our case, we're using either Google. We're using Google actually, but basically you could either use Google or OpenAI here. And then we're saying this is the actual agent itself. So up there, we're using create React agent. We're passing in the tools. We're using some kind of memory for our agent. This is the prompt, is our system instruction, which we defined above, and then our response format. So basically, what type of output are we expecting each time the agent runs? For invoking the agent. So if you're familiar with LangGraph, this is basically how you invoke an agent in LangGraph. So we're doing this. So this is basically just really LangGraph, a simple LangGraph agent, right? This is how we get our agent response. And these are the supported content types that we want our agent to support. So that's it. You set up your agent. So that's the very first step. Now, this is where the A2A stuff comes in. You always have like a server and a client solution. So this is what our server looks like. Now, this is how you actually work with A2A. So we've already installed A2A. By the way, I have all of this inside the GitHub, so you can install it. I'll also drop the links in the description of the documentation so you can see exactly how you can pull some of these. So now, one of the things about A2A is because it's a web application, especially on the Python side, they have this Starlet application. This is basically what allows you to serve your agents through a web server. So this Starlet application is basically UVCon, allows you to serve your application. So in this case, I'm actually using Fast API to serve my application because I wanted to serve both the agent as well as the Slack app. So basically, we're going to be using the Starlet application. And then you have a few other utilities which they provide, like request handling for tasks, for handling your tasks. Remember, we talked about tasks being very important each time your agent runs. So we have that as well. We also return things like types to define our agent capabilities, our agent card, and all these types of things. We're pulling in our agent from our definition from earlier on, so our agent, and then we have some Slack specific stuff which we're using to manage Slack. We'll talk about the client very, very shortly as well. I'll show you what that client looks like. So basically what we have here is like we're defining these are our agents, right? So we say, well, what is our agent? What's our agent all about? So we want to give our agent some capabilities. We want it to be able to stream, we want to push notifications. So we talk about streaming notifications as things happen. Now, here's how we define the scales. So the scales are all those functions we did earlier on. So we want to define them over here. And here's what our agent card actually looks like. So a name, a description, the URL, what version it is, what inputs are allowed, what outputs are allowed, these types of things, and then what capabilities and skills. So this is basically the key thing. Now, what this does actually is to create this JSON and a route basically that allows any agent who's calling our agent to see that first before they can interact with the agent. So this is just basically what actually makes it interoperable, is that you kind of have that identity. So any agent is calling me, oh, here's what I can do. Here are all the things that I do. Here's the skills that I have. So this is how you can use me, right? This is what makes it possible for you to use it across different frameworks. All right, so here we have just basically initializing our client server and things of that nature. So this is all that is going on here, and initialize now startup application. And this is how we're basically serving up our Slack events. So we could use Slack here as well. Now, the other thing that is so important here is your agent executor. So this is the other piece that is very important. So this is how your agent is going to be executed upon. And so basically, this is what this is intended to do. So you define a class called agent executor. You want to make sure you initialize the agent specifically that you're executing for, and then you define your execute method. So this is basically how we want to execute our function. This was gotten from from one of the examples, essentially, and this shows you exactly how you can define all of this. Now, there's so many things going on here, but I think all you need to know is basically this is how you execute this specific agent. Now, on the client side, this is how we interact with an agent. So, like I said, every agent once created has this well-known agent.json URL. So basically, this is where all the information from your agent card lies. And this is a function. This is on the client side. This is the function of how we interact with an agent. So first, we want to get our URL for the agent. We're hosting on local host 1000 or 10,000. And then this is where we basically do some HTTPX calls. There's a resolver where you pass in the client as well as the base URL of your agent. And then you want to grab the card to see what the card is all about. And this is where you send your payload to. So this is how you send your payload to. So we initialize our client here. We send a message payload to say, oh, here's our message here from the user. We send a request and then we get a response back. Now you can decide to handle different things going on during a particular task. So you could look for specific statuses. You could look at specific artifacts, and parts coming back from your response, and you can handle them however you want. So I think that's one of the cool things. Is like you have all these different events or notifications coming back, which you can handle however you want to handle them, and then you can now send your response back. So that's essentially how it works. That's how easy it is to work with A2A. I'll say that the documentation is a bit tedious to handle, but try to at least simplify that in here. So let's see what our agent looks like in action. Let's go try it out. So to try our agent out, I'm going to do this in Slack. So we have our agent already wired up in Slack. Now, this is a very simple prompt here. So, research Apple stock summary, and my expectation is that the agent should be able to just go pull this information in. So Apple last closed at 197 and the volume of this on today's date, and you can see that response back. Now, I've also added a way for you to see a metadata of the task itself. So you can see each task there's a task ID for each task. You could also see exactly what's going on, the input, the output, all of that stuff. And also, I usually love to do this with LangSmith as well to see the full picture of all that is going on. So these are all the runs I've run recently. So this is the latest run. So you could see the input here, get me Apple stock summary. And you can see the output. There's a tool call here where it's getting stock summary. it pulls that information in. So you can see that it gets that and then returns the response back. And you can see our structured response right here, right? So that was what we defined earlier on. So this is a very quick overview of agent to agent, how it works. Check out the GitHub repo so you can see exactly what that implementation looks like so you can adapt to what you're looking to do. If you have any questions, please drop them in the description below. Now, I think what I would say is this, right? There are a lot of protocols that are coming up and we're going to see more of them. Now, we don't know which ones are going to stick, which ones are going to be great. I know for sure MCPs have been great. People are building on MCPs. With A2A, we have to wait and see exactly how that pans out. Now, my hot take or not so hot take is that when I look at these different frameworks, I look at LangChain as an example. And in my opinion, LangChain feels to be like self sufficient. I don't quite know why I would need A2A explicitly, if I'm being honest with you. But that's just me. I think that you get everything you need. I think the way LangChain, for instance, defines things is great. So I would say if you're building agents, you can concentrate on building your agents on something like LangChain or AutoGen. And then if you have to kind of interoperate and things like that, you can start thinking about agent to agent. Now, one of the ideas that I have maybe is that probably might be a good way to kind of create things like agent marketplaces where you want to have multiple agents in there that interact with one another, these types of things. Maybe, but we're yet to see. We're yet to see. One thing I would say is that the documentation can be better. Google notorious for very very complex, complicated documentation. So it took me so much time going through all of this to kind of figure out exactly how this thing works. But I would say for sure, one to look out for as you're building. Keep building and have a great one. Cheers.